All right, welcome to this explainer, where we're going to transform your absolute nightmare of debugging minified production crashes into a seamless, honestly, highly satisfying process. If you're an IT support engineer, you know exactly the pain I'm talking about, right? You get an alert, a critical production issue's firing off, and the error logs look like they were literally written in an alien language. Well, today, we're going to fix that.
This quote right here, it perfectly captures the intense pain engineers face every single day. Debugging minified JavaScript really does feel like trying to beat a geometry dash level completely blindfolded. You've got all these randomly shaped pieces of a puzzle, but absolutely no reference picture to see how they fit together. But today, we're giving you your eyesight back by digging into source maps.
Okay, let's run through our agenda real quick. We're going to cover the gibberish stack trace, what source maps actually are, uploading maps to Sentry, verifying your integration, and then finally solving a real scenario.
So, Section 1, the gibberish stack trace. Let's talk about the cost of performance.
You know, the code you actually write using high-level abstractions like TypeScript, React JSX, or ES-Next is rarely the code that actually runs in your user's browser. Aggressive optimizations from bundlers and minifiers like Webpack, Terser, and EaseBuild are absolutely essential. They improve load times by boosting key metrics like largest contentful paint and time to interactive, and they do this through dead code elimination, tree shaking, and literally mangling your beautiful, highly descriptive variable names down into single letters just to save precious bytes over the network. But, as you can guess, this creates a profound observability gap.
And this comparison brilliantly illustrates our core problem. We have a massive structural industry issue where hundreds or even thousands of lines of logic get compressed into a single, meaningless line of random gibberish. An error reported at app.min.js line 1, column 45,678, that's entirely useless when you're trying to figure out which modular React component actually crashed. But contrast that with clean, distinct modular files, proper function names, and exact line numbers. It's a total night and day difference, right?
Moving right along to Section 2. What are source maps? The observability bridge.
So, the absolutely crucial point to understand here is that a source map simply acts as a translation layer. It's just a JSON file that provides a bidirectional mapping between those machine-optimized artifacts and your original human-readable source code. It basically taps your debugging tools on the shoulder and says, hey, that mangled variable a in your minified bundle, that actually corresponds to your original function named calculateTotal back in your specific TypeScript file.
Now, looking inside this JSON file, the mappings field is the real magic engine. It uses a special base64 VLQ encoding, which is essentially a highly compressed string of characters to precisely link generated positions back to original source positions in a super efficient way, without eating up massive amounts of storage. Also, you'll definitely want to note the source's content field. This one is optional, but incredibly critical for error tracking. It contains your actual raw source code snippets, which allows tools like Sentry to display the code surrounding an error, even if your original files aren't hosted anywhere publicly.
All right, Section 3, uploading maps to Sentry. Here's the procedural guide. Okay, before we upload anything, we absolutely need to talk about security. Source maps can contain the entire source code of your application. Exposing them publicly? Yeah, that allows anyone to reconstruct your proprietary codebase. So, to protect your intellectual property, you should always generate maps using a hidden configuration. This generates the map files, but stops your bundler from appending that source map URL comment to your JavaScript files. That ensures browsers and malicious actors never attempt to fetch them publicly.
So, here is the automated workflow you're going to need in your CI/CD pipeline. Step 1, generate those hidden source maps during your production build. Step 2, inject Sentry debug IDs. Sentry uses these unique IDs to flawlessly link your minified file to its exact matching source map, which totally bypasses the unreliability of file paths. Step 3, upload these artifact bundles to Sentry. The absolute easiest way to do this is using the Sentry Vite, Webpack, or Rolla plugins, which hook right into your after-production compile step. Or, alternatively, you can just use the Sentry CLI. And finally, Step 4. Ensure those map files are stripped or completely deleted before the final deployment so they never ever reach your production servers.
Section 4. Verifying your Sentry integration. Time for the troubleshooting checklist.
Automation is fantastic, but confirmation is definitely better. So run through this checklist. Go to your Sentry project settings under Source Maps and confirm your artifact bundles actually arrived safely. Next, check an event's JSON payload in Sentry to ensure the debug meta ID is present and matches your uploaded artifacts. And guys, here's the golden rule. Ensure uploads happen before the errors occur. Sentry does not retroactively symbolize events. If an error happens and the source map isn't there yet, that stack trace is forever going to be minified. Finally, verify your build process isn't zipping the artifacts before sending them. Sentry really needs them in plain text to parse them properly.
And finally, Section 5, solving a real scenario, the classic before and after.
Let's paint a picture here. Imagine you're running a sample React.js project on Sentry's free tier. A critical incident drops into your queue. Your users are totally blocked. You open the ticket, and you see this highly common front-end error. Type error. Cannot read properties of undefined. But without source maps, the stack trace is completely obfuscated. It just points to app.bundle.js, line 1. I mean, you have hundreds of components. Where do you even start looking?
Now, notice the difference once we implement our fix. Because we integrated our source maps and uploaded them via our Webpack plugin during CI/CD, Sentry has worked its magic. We go from a chaotic, useless minified frame straight to a deminified stack trace. We can zoom right into the frames, revealing the exact React component, hello world.tsx, right at line 42, with the original function name completely intact. We can even see the exact lines of code surrounding the error. What was previously an impossible, hours-long wild goose chase is now a straightforward 5-minute fix.
So I'll leave you with this question. Are your production stack traces ready for your next critical incident? Because if your errors still look like gibberish, you are flying blind out there. Implement source maps in your build pipeline today. Automate the upload to Sentry, keep them hidden from the public, and transform those unreadable production nightmares into simple, actionable bugs. Thanks so much for joining me on this explainer, and happy debugging.